All right, congratulations everybody. We are on to our final example for this lesson where we are finding the discriminant where the outcome gives us complex roots. So taking a look at this example where our quadratic is negative 5x squared plus 10x minus 15, we can imagine that our y-intercept is down at negative 15. We have a downward facing parabola. We may never come all the way up high enough to cross over and have a real solution. So let's see how that turns out. Our a value is negative 5, our b value is 10, and our c is negative 15. If we want to have b squared, we're going to have negative 5 squared. We're going to have minus 4 times negative 5. Oh, sorry, b. b was 10, wasn't it? My mistake. Let's go 10 squared. I'm sure somebody caught that. And negative 15 over here. All right, so that simplifies to 100 minus 300, or negative 200. Okay, if we have a discriminant that is negative 200, that means we are taking the square root of a negative number here. We're going to end up with an imaginary solution to that square root. We're going to end up with a complex solution overall because we are going to have our real part, that negative b is a real number, and then that real part with an imaginary part gives us what we call a complex number, as you should recall from our previous lesson last week. Okay, so with the discriminant being non-zero, there are two roots, but since that discriminant is negative, they are complex roots, not real ones. All right, and that is the end of today's lesson on discriminants and using the quadratic equation. I would recommend that you spend some time looking at that derivation of the quadratic equation if you're interested in that topic. Otherwise, just stick to getting comfortable memorizing that equation itself, the negative b plus or minus the square root of b squared minus 4ac all over 2a, and you will be good to use it to plug and chug and get through any type of question and solve any type of quadratic equation for its roots. All right.